Hi, and welcome back. My name is Johanna, and today we're doing Math AA Standard Level 2.4. 2.4 is all about the domain and range of a function. So first of all, what is the domain? The domain is all the possible values of the independent variable, the x variable, of a function. Meanwhile, the range is all the possible values of the dependent variable, which is the y, of a function. So what you learn in this chapter is how you write the domain and the range and how you find the domain and the range. So if your data is discrete, then it is graphed as separate points. So the domain and range are just lists of numbers. It could be, oh, the domain is 1, 5, and 6, and the range is 7, 8, and 10. That was just random, but it's just a list of numbers. Meanwhile, if it's continuous data, it is graphed as a line or a curve. So therefore, the domain and range are written as inequalities, sets, or interval notation. So an inequality, I'm sure you are very familiar with these symbols. They have probably been used in your education many times before. But essentially, if you don't know, the open side of the arrow means that the thing on that side is bigger. So if I put an X on the open side and then a 3 on the smaller side of the arrow, that would mean that X is always bigger than 3. Now, if there is a line under the arrow, that means bigger or equal to, or smaller or equal to. So that means that X could be 3 or bigger if I use the same example. When I use the word sets, I don't mean like literally a set, because then you could think like the same thing as a list of numbers, but no, I mean if you were to say all real numbers. This is what I have written here. I've written that the domain, the x, can be any real number. So when you write this, it's a weird E and then an R with like a double line. Now, if you have some more specific domains or ranges, you might have to use interval notation. So you use these like bracket type things. And as you see here, I've written that the like square bracket when it faces the wrong way, or the normal bracket, means that those numbers are not included in the range or domain. Meanwhile, if you use the square bracket like facing the right, like each other, it means that the numbers are included. However, in the book, it does say that they prefer you not to use normal brackets, like avoid using the normal bracket, like the unsquarey bracket, because it could get confusing with all of the other numbers you are using, since brackets are very commonly used. So the last thing for this chapter, before we get into the examples, is a piecewise function. Essentially, this means a function that has two or more equations for different intervals of the domain of the function. So this could be like a function where it is going really hastily, like it's exponentially increasing, and then suddenly it just plateaus, as in like it goes from a line going up and then suddenly it's just flat. This means that there are two different equations for the different x values, the different domains, right? Because one equation would not give you that type of graph. So now to start with the examples, we're going to do 2D. Now ignore what I wrote about A. A is not interesting, but look at this graph right here, and you might have to pause, and we're going to decide what the domain and range are. Or just the domain. I don't really remember what I wrote. I assume I did both. So first of all, if you look at the graph, if you go back and look, you will see that the x values go on forever. As you can see, these arrows, they go on forever. So we would know that x is all, or the domain is all real numbers. Now, y is a little more interesting. From y, you can look that it only goes in between 3 and 5. So this is how you would write that. The domain is x can be all real numbers. And the range is, okay, y is bigger or equal to 3 and smaller or equal to 5. That is how you would write that. Now for the next example is from 2E. So for this question, you're going to have to remember what we have done previously with interest. So he invested £10,000 in a fund that is an annual interest rate of 2.5 compounded monthly. So part A is to write an equation to represent the situation. So now you have to remember how the formula for compound interest is done, and also how it is done over a non-yearly period. So this is essentially what I did. Usually you would see P times 1 plus R divided by N to the power of N times T. That is how the formula looks like. Equals A, of course. I just didn't write that there. I don't know why. B is explain why this equation is a function. Now, this is a function because for every value you put into t, you will get a different y value. You will never have the same value. So it passes the vertical line test because you would never have 2 points at the same time. Now, C, you have to state the domain and the range of this function. So the range would be that y is bigger than 10,000 because obviously you put 10,000 in from the start, so it's just going to get bigger and bigger, or it should be like that. And then for the domain, I'm changing it from x to t because obviously in the question we're using t, not x. So t can be any real number, like any amount of time, because t represents, right, the years. But t cannot be less than 0. It can be equal to 0, but it can't be less than 0. Now D, how long will it take for this guy to double his money if he does not make any additional deposits or withdrawals? So he wants to double it. And so basically we're trying to find y, and we're trying to find when y is 20,000 instead of 10,000. So I just plugged it into the formula and then isolated t. You do have to use logs here. I will be making a video on logs soon. I mean, you don't have to use logs, but I think it's the easiest way. Yeah, I will make a video on logs soon. So if you don't know how to use logs, then we'll figure it out together. But at the end, T came out to be somewhere around 27 years and 10 months. I think it was like a little less than that, but around that number. Yeah, because I got 27.8, but obviously 0.8 of a year is not 8 months. 0.8 of a year is like 9.6 months or something like that. So, you know. Yeah, goodbye. Thank you. That was it for today. Feel free to subscribe, like, comment, and follow me at Johanna Frennert.